Hello again. I had done the previous video and then I walked down the hall to go to the bathroom, and as I walked back I had an idea that I needed to make another video, some things that I wanted to share with you. So I just Googled trig identities and had all these different cheat sheets or formula charts that showed up. And so I want to talk through one of them, and you'll see how this ties into the sum and difference identities in just a second. So on this, the quotient identities, I expect you to be experts at. The Pythagorean identities, I expect you to be experts at. I will give you the formulas for the sum and difference, and I would give you the formulas for the double angles. In the past, we have taught half-angle identities to PreCal. I don't know that we will this year because of COVID. These are a little bit, we have used these in, my brain just stopped, in HL, but they're a little bit beyond the scope of what we've done. But sometimes we'll see problems that deal with the even odd identities or the cofunction identities. Well, I don't have these memorized. The even odd, actually, I like to think about that in terms of the unit circle. So like if I'm on the unit circle and I've got an angle theta and then the negative theta down here, notice they would have, I didn't draw it correctly, but basic idea, they would have exactly the same cosine, which is why cosine of negative theta equals cosine of theta. But the sine value, it would be the same length, it would just be in the negative direction, which is why we have that right there. Okay, so those, I don't necessarily, I can get to those when I think through what's happening, when I think about the unit circle, but they're not necessarily something that I have memorized. These down here, these cofunction identities, I don't have these memorized at all. And so I either have to think through them with the unit circle, or what I can do is I can use the sum and difference identities. So let's pick one or two of these. Maybe we'll say, okay, so sine of pi over 2 minus theta. Sine of pi over 2 minus theta. Well, this is the sine. Sine is sine cosine. Same SIGN, cosine, sine. Okay, and now what I know is that sine of pi over 2 is equal to 1, but cosine of pi over 2 is equal to 0. And so this is just equal to cosine. So all of these identities here, they're calling them cofunction identities in this box. I don't have those memorized. I don't expect you to have those memorized, but what I would do is I would use the sum and difference properties to get them, again, if I needed them. Or I would Google it. Depends on the world you're living in. It could be something like, what is cosine of theta minus pi, or theta plus pi? I don't know. You can think about that in terms of the unit circle. If this is my theta, add pi, and I'm down here, and so I expect the answer to be negative cosine of theta. But we may not know that, it might be hard to visualize. What happens if this had been, instead of pi, if this had been pi over 4? Well, then that's just weird, and who knows what's going to happen. So, maybe we'd rotate it pi over 2, I don't know, whatever. Okay, so cosine is cosine, opposite SIGN, sine, sine. And then cosine of pi, that's over here, that's negative 1. Oh, sorry, cosine of theta times negative 1. And then minus sine of theta, sine of pi is equal to 0. And so sure enough, this is equal to a negative cosine theta, which is what I expected. But my point is that all of these identities, I don't think about them. I don't use them until I like to think about those problems after I've already seen the sum and difference. And you can even do something like a tangent of negative theta. Well, this would be equal to tangent of 0 minus, that's not a theta, there's a theta if we wanted to do that. And then tangent, notice I picked sine, cosine, and tangent just to give you experience with different ones. Tangent of 0, then it's the same SIGN divided by 1. It's the opposite SIGN, tangent of 0 times tangent of theta. Well, tangent of 0, I don't think unit circle as much as I think my tangent curve. Well, that's 0. And so this is 0 minus tangent of theta over 1 plus, 0 times tangent of theta. Notice this right here goes to 0. That I don't need to write. Well, I need this. I don't need that. And so I have a negative tangent theta divided by 1, which is just negative tangent of theta. So maybe we knew that if my angle here is tangent value versus the negative, they would have the same, the slope, one of them would be positive, the other would be negative, but it would have the same number. So maybe that, anyway, you'll see these as come up and whatever, but I just wanted to talk about how I like to use these after I've already looked at the sum and difference identities. All right, go practice.